Now in chapter 3 we studied about motion in a straight line. That is, if we have a point object, then this point object, it can move either to the right or to the left, or it can move upwards or downwards. And if it moves in this direction, then we denote that direction as positive. If it moves in this direction, then the direction is denoted by this negative sign. If it moves up, then we indicate it by the positive sign, and if it goes down, then we indicate it by the negative sign. So these signs, positive and negative, they give account of the direction of the motion of the object. As in this case, it's moving in a straight line, either to the right or to the left, or moving up or down, or you can say it moves along the x-axis or the y-axis. Then we use positive and the negative sign to indicate the direction. But in this chapter, chapter 4, motion in a straight line, your object says moving in this direction. It may move in a straight line, or it may not move in a straight line, but it moves in, say, in this direction. Then how will we indicate the direction of this object moving in this direction? We cannot use the positive or the negative sign to indicate the direction. So here in this chapter we shall introduce the concept of vectors. So vectors, what is a vector quantity? Now a physical quantity may be a scalar quantity or a vector quantity. A scalar quantity is a quantity which have only magnitude but no direction. And a vector quantity is a quantity which has both magnitude and a direction. And it also obeys the law of vector addition, which is the triangle law of vector addition and the parallelogram law of vector addition. So a quantity which has both magnitude and direction and obeys the laws of vector addition is a vector quantity, or are known as a vector quantity. For example, displacement, velocity and acceleration and force, these are all the vector quantity. They have direction and magnitude as well. Now how will we denote this vector quantity? We know that it has got magnitude and direction. So how will we denote a vector quantity? So a vector quantity is usually denoted by any letter. Okay, we have A, B, C, D, or let us take for example the velocity V. So this velocity is a vector quantity. In order to denote this velocity as a vector quantity, we draw an arrowhead above this letter. So here you have velocity. This arrowhead will indicate that this velocity is a vector quantity. Now a vector quantity has got direction and magnitude and direction. So here this vector quantity is equal. Remember, it has magnitude. So the magnitude is denoted by the modulus of this v vector, and the direction is denoted by v with this small cap over the letter v. So this indicates magnitude and this indicates direction. So vector has got magnitude and direction. So this is how you'll denote a vector quantity, or represent a vector quantity, where this is called a unit vector. It only gives you the direction. This only gives you the direction. It is called a unit vector. So it only gives you the direction, and this is the magnitude of the vector. So this modulus of the v vector is the magnitude. So you can also write this modulus of V, or the magnitude, in this way. So we have V vector. This is equal to, simply writing it V without the arrowhead. This will indicate magnitude. Then we have V cap. So you can write, denote this vector quantity V vector as V cap, or V vector is equal to modulus of this V vector and V cap. So this is how you will denote a vector quantity. For example, acceleration also, you have A vector is equal to A cap. Displacement also, you can write it as S vector is equal to S cap, or any vector for that matter can be represented in this way. So in general, you can represent a vector by a letter A vector, and this is equal to A modulus of A vector, then A cap, or you can also represent this as A cap. So here A, or this one, is called the magnitude. So we have A vector, this modulus of A vector, or A is the magnitude of the vector quantity. And this A cap gives you the direction. It is called a unit vector. Is a unit vector. It only indicates direction. So we have the magnitude and the unit vector, which only indicates the direction. So here you can see from this formula, you can write this unit vector, this A cap, is equal to A vector divided by A. So here A cap, if you want to find the direction of the vector, then you divide this vector quantity by the magnitude of the vector quantity. Then you will get the unit vector. So in this way you can write any vector as A, B, C, D, a letter with the arrowhead. Now we shall come to the definition of position and displacement vectors. So here, suppose we have the XY plane. Let us say the object is at this point, P, and it moves in a curve, say in this manner, to this position, P dash. So it moves from P to P dash. Now the position of this object obviously can be taken by this X and the Y axis. You can write here XY and here X dash, Y dash. That will indicate the position of the object, or you can use the position vector as OP. So if you draw a vector from starting from the origin of the XY plane to this position here P, then this vector OP vector is known as the position vector. Similarly for this P dash also, if we draw a vector starting from the origin to the point P, remember you'll have to give this arrow also. Alright, so I'll write the arrow here instead of here. So this OP dash, this is known as the position vector. So in this case we have the position vectors OP Remember, how do you indicate the vector? By drawing the arrow above the vector quantity. So here OP with the arrow head, and OP dash is also with the arrow. So this OP and OP dash, this will give you the position vector. And you can see here the arrow is from O to P, which indicates the direction is from O to P. Here also O to P dash, the arrow is from O to P dash, so it starts from O, then it goes to P dash. Alright, so that will give you the position vectors. So a vector which is drawn from the origin to any point on the xy plane is known as the position vector. Then we have the displacement vector. Now the displacement vector is a vector which is drawn from any point of the xy plane to any point. Okay, so from the initial point, you can say, to the final point. For example, here the object moves from P to P dash. So a displacement vector is a vector drawn, okay, a straight line. So this is the vector drawn from P to P dash. Okay, so I'll drop all these paths. Suppose your let's say the path will be in this way for clarity, so it moves in this way. So this displacement vector is a vector drawn from one point to another point of the xy plane. That is called a position vector. So here in this case you have P dash to be the displacement vector. So here we have the displacement vector. Displacement vector P dash, from which position it starts, from position P, it ends to position P dash. Okay, so here this will give you the displacement vector. Now there is a relation between the displacement vector and the position vectors. And that relation can be obtained by using the law of vector addition. Since I haven't tell you about the law of vector addition, I'll just explain to you this relation. So the relation between the displacement vector and the position vector is given as P dash vector. Now this is equal to, first you take the final position vector, which is OP dash vector, then minus this with the initial position OP vector. So this is the initial position, final position, and this is the initial position vector. So hence the displacement vector is equal to the final position vector minus the initial position vector. Remember in the chapter 3 we did displacement as delta x. This is equal to final position minus initial position, isn't it? So this is the displacement. We have the final position minus the initial position. So here also this is the displacement vector. We have the final position vector minus the initial position vector. So this is the relation between the displacement vector and the position vectors. Now we shall come to equality of vectors. Now two vectors, say A and B vector, are said to be equal only if they have same magnitude and same direction. So here we have two vectors A and B. Suppose your vector A is in this direction. So this is your vector A. Then the vector B will be equal to this vector A only if it is in the same direction and it has same magnitude. So the magnitude is from here to here. So this indicates the magnitude. The length of this vector indicates the magnitude. So here vector B is equal only if it has the same magnitude, same length, and same direction, in this direction. So this is a vector B which is equal to the vector A. So in this case you have A vector to be equal to B vector. So these are equal vectors. Same magnitude, same direction. Equal vectors. Now suppose if your vector B is in the opposite direction. Suppose it is parallel to this one, but it is in the opposite direction. Then in this case, the vector A has the same magnitude as the vector B, but the direction is different. A is in this direction, B is in this direction. So such vectors are called opposite vectors. And we denote opposite vectors by putting a negative sign here. So this is read as A is equal in magnitude to B, but it is opposite in direction. So here A is opposite in direction to B, but it has an equal magnitude. So this is how we'll indicate or denote opposite vectors. Now suppose we have another case where your vector B is in the same direction as A, but you can see the magnitude is larger than this A, isn't it? So here this is the magnitude of A and this is the magnitude of B. So it has got same direction, but the magnitude is different. So B is much more larger than A. So how will we represent this vector which has same direction but different magnitude? So in order to represent this vector, what we do is we write first B since it is larger. So B vector, this is equal to, now suppose the length is this much and this is twice, isn't it? Twice. So the vector B is twice that of A. Okay, so it's like having 2A. So it's like having two A vectors. So the B vector is equal to 2A vector in magnitude. Alright, so here what we'll do is we'll just multiply this 2A vector. Okay, we cannot multiply the direction, we'll have to multiply the magnitude. So in magnitude, if we have the magnitude, if we take just the magnitude, B is equal to 2A. So this indicates that the vector is in the same direction but have a different magnitude. So in general, what we can do is that we can multiply this, or this 2 can be taken as lambda. It can be any number, not just 2. It can be half, it can be 0.3, 0.4, it can be 4, 5. So in general, we'll write this in this way. So we'll remember we have to multiply the the magnitude of the vector. Okay, so all these vectors which I've told you just now, they are parallel vectors. Okay, you can see A and B, they are parallel to one another. But what if they are not parallel? Suppose if vector A is in this direction and vector B, say, is in this direction. This is the vector B. So if we have such case, then these two vectors, they are not equal to one another. Okay, so they have different direction, they may also have different magnitude, so they are not equal to one another.